Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience, who would be curating the RealSci_Nano Twitter account.
Hi everyone, today we have with us Eleonora, who is a teaching fellow at Imperial College London in the UK. Hi Eleonora, how are you doing?
Hi, I'm good, thank you.
Okay, super. Let's start by understanding your scientific journey so far. So, how did you end up in your current research field?
So that's a long journey that would probably start from when I was a kid, like many of us. I'd never even heard, so I work in material science, and I'd never even heard what material science was, as many of us would, and probably many students still don't have any clue of what it is.
Yeah.
But when I was a kid, I used to be that kid that probably every parent would hate. That would just mix up everything that was in the house. You would get just toothpastes and gels and oils and foams and literally anything. And then I would just take a random plate or a Tupperware and mix it up, and then forget about it for a couple of days. So it would stink, it would be horrible. My mom would hate me, but I would think it was cool. And I would think that I was just making great science. Clearly I wasn't, right? So yes, that's pretty much where I started. And then when I started kind of growing a bit more and understanding that you could also look at materials differently, I started getting super interested into the glow lights, the sticks, that when you break them in half, they glow in the dark. And I was like, whoa, that's fascinating. So I bought like a bajillion of them. I started cutting them to mix the chemicals separately. And then I realized that they were extremely toxic. But yes, and then I started ordering like ferrofluids, aerogel, stuff like that, basically. Like I was really interested in materials that would do crazy things. But I'd never, even at that point, I'd never even heard of what material science was. So I think I was always interested in going into pretty much everything else, like architecture and design or physics. But then somebody showed me a video of one of the professors in my college back in Italy that was doing these kind of outreach experiments, and he was showing what a shape memory alloy was. And seeing this spring that it's a metal and then it gets deformed and then you just pour some hot water on over it and it just goes back to its original shape was fantastic to see for me. So yeah, so then I figured out, okay, this sounds really interesting. Maybe that's a good idea to get into. And then I got into the course and it was all physics and maths. Okay, maybe this wasn't the best choice. But no, I ended up really enjoying it. And I've always been very scientifically minded. I've always just liked sciences in general. So I've then, this is a long story, I'm sorry.
Okay, go on. It's interesting. Go on.
I've then got interested in biomaterials. So materials that would be useful for the human body and replacement of human tissue, for example. And as I was doing my undergrads in Italy, I got told that I could have done a master's at Imperial because that's where biomaterials were being carried out. At the moment when I was doing it, there was actually no biomaterials masters in Italy, in the whole of Italy. So I decided, okay, I'm just going to go to London for a year, study this master, and then come back and carry on the studies. Right. I did the master's and then I got offered the PhD. And when people offer you money to study, I was like, yep, I think I'm staying here. That's what I'm doing. So yes, so I pushed through all of my studies. I did my PhD, and my PhD was in smart materials. It wasn't initially, and then I kind of molded it into being smart materials because I really wanted to work on crazy stuff.
Because you're smart, huh?
And yes, so I worked on these materials, which were graphene composites, with different capabilities, whether they were being self-healing or shape memory or sensing. And then I carried on my PhD doing exactly the same thing. And finally, I've done loads of outreach work throughout pretty much my whole life because I really like science communication. I really like talking to kids, particularly like showing crazy materials to kids, because they're the easiest to amuse, and they'd be like, "Oh my God, this is so cool!" If you show something like that to a scientist, you would not get the same reaction. So I then found this position, which was still in my department. I've pretty much been in the same department for like 10 years now, which was a teaching fellowship, which meant that I could teach undergraduate courses, I could do a bit of research, and at the same time I was in charge, and I am still in charge of them, outreach in my department. So I do loads of that too. So that was my full journey, and that took like half an hour, I feel. So I'm sorry for who's listening.
Don't worry about it. It's all fascinating. So, starting from mixing gels and toothpaste and whatnot, since you were a kid, to now being in charge of people and teaching people material science, that's an amazing journey you've had. Um, and so, your current research, so where does it fit in this big picture of materials and nanoscience and this big puzzle? Where do you see it fitting?
In the smart materials field.
Right.
Into making these composites, which are still smart, whether you're doing self-healing polymers or self-healing composites or shape memory. So I've kind of tried to work on a material that would do as many things in once as possible. So I've managed to achieve a material that would be self-healing, shape memory, and sensing at the same time, which was really cool. So it can actually sense damage as well. So if you're breaking it, it can sense where it's being broken. And at the same time, it can reheal. It's really, really cool. Yeah, I know.
It's so cool. That is so cool. So you're making super materials.
Pretty much, I would say so.
Smart materials, of course, but wow, that is so cool. So it sounds to me that you do a lot of interesting experiments, and you have done super interesting experiments also when you were a kid.
Yep.
Your mom might not agree. But if you have to pick one research project that you're most proud of, or the most fun or quirky one, I know it's difficult because it sounds like you have done quite a lot of interesting experiments and research projects. Could you pick one and explain it to us in simple words in the section we call In Other Words?
Yeah. I think it would be what I've just mentioned, which is when I managed to achieve a material that could do all of these things in one and be like the supreme smart material, which could be part of a film, right?
Right. Absolutely.
So this material was made by, what I did was making a super light graphene foam. And graphene foam meaning that you literally make a sponge, and this sponge is completely made out of graphene. And graphene being extremely light and extremely superconductive, it was really easy to have as a network for whatever other material you were using. And I collaborated with a company in Spain called CIDETEC, which is a mixture between a company and an institute of research.
Right.
And they were producing these polymers that had the capability of both shaping, so self-shaping, and having shape memory capabilities, and self-healing at the same time. So working with them, we managed to infiltrate to put basically these polymers inside my graphene networks, obtaining something that was incredibly useful. So basically, when you've got this graphene foam, the graphene foam can conduct electricity through it. And when it conducts electricity through it, you're basically passing heat within it, meaning that since the material itself is self-healing, when you cut it in half and you put the two halves together to let it self-heal, it would normally take a while, like it normally takes about 24 hours to heal. But if you pass a current through it, it will take about 5 minutes to get to its original strength, just because you can pass some current through it. And the other optimal thing of graphene is that you can also use it to detect where damage is. So since you've got this crazily interconnected network, if you have a crack, a fracture in your material, then you would be able to see the resistance of the material dropping, because the graphene network is actually reducing the amount of surfaces in contact, so the conductive surfaces. So that was sensing damage. It could also sense when you were compressing it, because again of this graphene network, that if it was being compressed, it meant that surfaces were getting closer to each other. It meant that the resistivity was changing as well. So it could act as self-healing, sensing, and shape memory at the same time material, which was awesome. I really, really enjoyed it.
That sounds really interesting. Could you talk about where can this material be used? If I
Yeah.
find out.
So yeah, no, initially I was funded by DARPA, which is the US agency for defense, basically. And we were funded to try and make a material for armor that would be able to self-heal at sense whether an armor had been damaged. So it's something that you could use there. However, it's not as strong to be able to behave like armor, clearly.
Right.
But it's got some shear thickening capabilities, so it meant that it would be good to absorb shear as well. And you could use it as a robotic skin, for example. So where you've got a robot that needs to to have the same properties of a human skin, where it can sense damage, it can sense pressure and tension, it can then reheal once it's been broken,
Right.
and it can manage to mold and move around. Yeah.
So it's like in what they show in these superhero movies that if the suit breaks, it just heals itself magically.
Yes, exactly.
That's exactly
However,
what it did.
However, so far I can make only about a couple of square centimeters of it. So.
You start somewhere, right? You start with
Right.
small wounds, and then at some point you get to the entire length of the fabric.
We'll get there.
Absolutely. That I can imagine why you picked this as the one that you're most proud of, because that sounds like an amazing project. That is so cool. That is amazing. So Eleonora, let's move away from research a little bit and go into the other parts of a scientist's life, which is teaching. So do you teach? And if you do, which courses would you like to mention?
Yeah, I do teach, and I do teach the first year undergraduates. And I've been recently given this course, which is called Design Study,
Right.
in material science, which was basically designed by one of our awesome academics, which is Luc van der Veer. And he's a genius in our department. And he's designed this course for students to understand how to work in a company and how to make a product from the beginning to the end with all of the tools that we would have in our department. And this was something that was really cool because third year students normally were doing this course, and now they've decided to shift it onto first years, which had great big challenges where you've got first years that know nothing about material science and they have to try and make a project out of completely nothing. So yeah, I'm giving them all of the basics to understand how to sketch, how to do SolidWorks, to integrate designs into 3D works, and to then print their materials, laser cut, machine them, and automate them with Arduino as well. So they can, in the end, they can get to a finalized product that they need to present as a company. So they've got many things and many steps throughout all of this. And at the end, they've got a finalized product. So yeah, it's a pretty cool course. And I also teach material selection. And I teach particularly the labs in material selection and the labs in rheology. So yeah, it's been all challenging with the pandemic, but we've got through it.
That sounds really cool, especially the first course. It sounds to me that you're shaping tomorrow's entrepreneurs.
Yeah, pretty much. I think I'm just trying to give them the capability of working in teams where possible, because it's something that they need to learn, because that will happen everywhere. And to learn how to use all of the tools and equipments that we've got in the department as a start, which is a great thing for them. So we've actually bought about 9 new 9 new 3D printers that only these first year students can use, so nobody else has access to. And we've done it so that they could use and focus them onto their design study. And we've got a laser cutter in the room just for them. So yeah, it's all well structured.
That's really cool. So is there like a competition at the end of the course where
Of course there is a competition. Otherwise students don't get motivated. There is a competition where you actually, at the end of the course, you will get a sort of an interview panel, and the interview panel has people from different sectors in industry as well. So that's also a plus for the students, because they get to see big people from either Royce or from Deloitte or Rolls-Royce, like whatever we choose, and we select the different panel from. And then there is a prize at the end, of course.
Of course. Of course. Oh, that sounds amazing. And also the second course that you mentioned, selection of materials. So is it the one where you tell or teach students, of course, how to select the right material based on the environment or the need or
Exactly, based on the property that you want them to get to. So this course is the module leader would be Florian Bouville, who's a new lecturer in our department, and he's also amazing. And I'm just in charge of the laboratories that are part of this course. So I'm teaching the students how to do tensile testing, bending testing,
Right.
how to learn how to do hardness tests, how to check the thermal and electrical conductivity of materials and their density. So they all need to learn all of these skills before they get towards the deeper stuff of material science.
Right, in order to make an informed decision about selecting the material. That sounds
Do not ever choose chocolate for a teapot. It's not a good selection.
not a good idea. No, no, no. Okay, wonderful. So this all sounds amazing. The research is amazing. Teaching courses, those are also amazing that you're doing. However, if you have 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything here.
Yeah, even because you wouldn't be able to give me those things.
Sorry.
No, it's all right. So I'm gonna go a bit serious here. I think that academia is a wonderful place to work in general, but it's a wonderful place to work if you're not, if you are a white man, pretty much. That's how it is. Because there's a lot of, unfortunately, there's stereotypes involved. There's not much place for women and diversity, people of color, LGBT plus communities. It's just really difficult to be heard if you are in one of those kind of fringe groups, even though they're not fringe. We are all part of the society. So yeah, I would just like there to be more representation and more understanding and communication that could be where people can be heard and can be seen for what they do and not just for their either aesthetics or who they like. It's just really frustrating because you can see the statistics and it's still a very, very big issue within academia, unfortunately. So I would love if you could sort that out. Thank you. That would be fantastic. And yeah, so I would also wish for diversity and representation, clearly respect. I think I'm just exhausting all of my wishes here. And there's also the issue that unfortunately academia is very based on winning, so on who publishes the best paper and who is the best at all of that, whereas research should mostly be based on improving our society. And again, that's not right now as it is, because the most important thing that you could do is publish a paper in a really good journal, which shouldn't be the case. It should be a really good paper, which can be then reproduced. But yeah, so there's a few of these things. If you can just pick 1 or 2 and then sort them out, I'd be grateful. Thank you.
Oh, okay. I'll try my best. I'm trying my best.
Thank you.
To improve. I mean, I agree with all of your wishes that you mentioned, and I wish I could just snap my fingers and be like, yes, that's what is happening from tomorrow. When you wake up tomorrow, Eleonora, this is how the world is going to be.
Thank you.
I wish I could do that, starting from the respect, inclusion, diversity, representation. I think it's all interlinked.
Yeah, exactly.
Extremely important for academia and rest, like other parts, walks of our life as well. And you're absolutely right. Quality over quantity should be the norm when judging an academic's performance, so to say. I think that's very, very important.
And that's why I'm doing loads of teaching and loads of outreach, because I think it's probably the easiest way to try and change that. So if I go and get kids before their GCSEs, then maybe they'll get interested in that. And there will be more representation, better role models. Yeah, that just needs to be a chain of events happening there.
Exactly. And the best thing is you're doing it, you're actively doing it and not
Yeah.
waiting for it to happen.
No.
Which is something which is extremely important because I mean, of course, you can ask for it, but you also have to actively do something about it in whichever way and form that you can, which you're doing, which is amazing.
Yeah.
So I would like to believe though that even if that is not the reality right now, that's not the normal right now, hopefully we are working towards it collectively. We have to work towards it collectively, of course. And we will soon, better late than never,
Yep.
I would say,
Yes.
achieved all this diversity, inclusion, representation, everything, and also quality over quantity. I think that's
Agreed.
extremely important.
Hmm.
Um, and hoping for the bright future.
Yeah.
Speaking of which, what are you looking forward to in the next 3 months?
Holidays wise, or of course holidays. Um, no, so I'm in charge of redoing again for the second time in a row all of the labs for the undergrad students, because
Okay.
clearly we've been during the pandemic, and it meant that a lot of our undergrads will have to stay home now and will not
Mhm.
be able to come into our labs. So if
Right.
earlier we could just get them into our labs and show them our amazing machines and have them learn how to use them. Now we've got to just reinvent everything from scratch.
Of
Um,
course.
exactly. Why not? Just to
Right.
make our lives slightly more complicated.
Absolutely.
Um, so, so I am working on that. And at the moment, I'm just working on making infinite kits so that students can receive their own materials at home, and they can do their own testing at home. It's going to be challenging because we've got all around 100 students per year. So 100 kits to be shipped all over the world within a couple of weeks will be a mess. Yes. So I'm looking forward to that part being over and to everything being sorted.
So you are creating or preparing kits to
Yeah.
be sent out to students all around the world
Yeah.
to enable them to do experiments, science experiments at home.
Yeah. Yes. So what we had to restructure everything. Told you. So the material selection labs that I told you that we were doing when they were needed to learn how to do tensile bending, electroconductivity, thermal conductivity, and density, etc. Um, I I'm basically redesigning with a team of people to make them work through Arduinos. So we bought some Arduino sensors, and we're trying to make a thermal conductivity sensor, an electric conductivity sensor, a density kit through Arduino, that everything could be operated through an Arduino board. And then
Mhm.
we're giving them a kit to do some hardness measurements as well with a
Mhm.
punch and several things basically. Um, so they should all be able to do all of this. And then we'll just supplement them with a few videos to explain how stuff works. They will get some data. It's going to be a long process, but
That sounds so cool. It's so
yeah.
innovative. That's amazing.
Yeah, you
That
have
is
to be
so
creative now. There's no other option.
yeah, now you have to be creative. But this is like one of the best things I've heard out of
Love to hear.
the creativity, like transitioning from teaching in the classroom or in the lab to teaching now from in front of the screens. This is amazing.
Let's hope it works. That's my worry.
I'm sure. I'm sure it will work. To whichever extent that can be talked about, but
Yeah.
I'm sure it will work. And yeah, this is amazing. This is so cool. That's so cool that you're doing it. It's very nice of you guys to do it, especially for students who can't really travel
Yeah.
um, to Imperial. Yeah, yeah.
I mean, in
Yeah.
some countries, apart from the restrictions, some countries' flights have become just insanely expensive. Like
Yeah.
to go from one place to another would be about 5 to 10 grand. But no.
Yeah, it's just not worth it. So you're bringing the lab to them
Yeah,
in a small way. That is
exactly.
so nice. That is so nice. So, Eleonora, before we let you go, what I want to understand from you is what are the big challenges faced by the field of materials or nanoscience that the scientists are working towards or rather should work towards solving?
Yeah, I think that I will pretty much go back to my previous answer of the wishes. I think that we really need to get a culture change to accept diversity and promote inclusivity. There's also an issue with mental health awareness, which I think it's not necessarily strictly regarding academia, but it's something that is often ignored by scientists and is brushed under the carpet as not very important. We really need to focus on all aspects of our well-being before we can be productive members of society and scientists. So we need to be able to ensure across support to everyone across the board. So that's what I think we are working towards. There is a community of us and there's a group of us that are already trying to do that. Hopefully we'll get somewhere with it.
Yeah, absolutely. It's a collective effort, and I hope we are working towards it. And hopefully, at some point, the kids would be like, diversity. What does that word mean?
Exactly.
Because that's the normal, right?
I really wish, yes.
That would be cool. That we don't need a diversity director or diversity representative, because you don't need it, because everywhere everyone is included, everyone is treated equally, no matter the gender, the origin, everything it's all fine. And what is diversity? I think that's what we should work towards.
I'm really hoping that we'll get to the stage where, so I am right now at the point of course, women can vote. They've always been able to vote, right? So I'm just hoping that we'll get to that stage at some other point. That next generation will be, of course, there's no diversity. What are you talking about?
Yeah, that's the normal, right?
Yeah, exactly.
Ancient times, people used to work on getting diversity and stuff, but now we live in the society where everything is inclusive and everyone is inclusive. Yeah, on that positive note of futuristic vision that we have, thank you very much for taking the time and speaking with us. And we are very, very excited to have you on Real Scientist Nano.
That's all right. Thank you so much for having me.
Thank you for listening. To know more about us, please visit our website, realscientistsnano.org, and follow us on Twitter at realsci_nano.